carry on where we left off with simplifying radicals, now we're going to look at simplifying monomial square roots, or really taking the simplifying radicals numbers and adding some variables to them. So we have this rule here: if n is the nth root of the square root of x to the m, kind of our basic form for a radical. We're going to say if m is greater than or equal to n, then the monomial can be simplified, and that's looking for the number of sets of n terms that can come out of the radical. So if this number is equal to n or greater than that, we can actually simplify it further. So let's look at some basic examples before we get some other things and what we're looking at here. So let's say I have x to the third, y to the fourth, and I want to find the square root of that. So that says that I have 3 x's and 4 y's. Now, if it's square root, we've talked about before that we're literally looking at a set of 2. So I have one set of x's, one set of y's, and another set of y's. So together that takes out one set of x's, it takes out 2 sets of y's, and it leaves us with an x on the inside. So we would say that this simplifies to be x y squared square root x. Now what if we change that to make it cube root? So now we need sets of 3. So I still have 3 x's, 4 y's, but now that group of x's here makes 1 x on the outside, 3 y's come out to make a set, and then we're left with 1 y on the inside. Kind of that leftover odd one left. Well, if we went to the 4th root of x to the third, y to the 4th. Well, I don't have a set of 4 x's, so that actually is going to stay in to be x to the third. My 4 y's here are going to come out, and that's going to give us a set of y's on the outside. So depending on the index of the radical, it changes to how it's going to simplify. Now what we can also start to do is think of like division. So I had 3 divided by 2 is 1 with a remainder of 1. 1 set came out, 1 left over. 4 divided by 2 is 2, which is why we have 2 sets of y on the outside. X to the third, so we got 3 divided by 3 is 1. There's our 1 set on the outside, nothing on the inside. 4 divided by 3 is 1 with 1 remaining, so it's the odd one left in the sets. 4th root, 3 is not bigger than 4, they all stay inside. 4 divided by 4 is 1, that's 1 set on the outside. So we're going to take this principle and use it to simplify the radicals. So we come down to the square root of 32x to the third. I'm going to split it kind of into 2 parts. I could do the square root of 32 and the square root of x to the third. As we do other problems, we won't typically split them, but right now it's kind of good to think of the 2 different parts as we solve. So first thing I'm going to do is simplify 32. 32 is 16 times 2, which gives me 4 and 4. I could go further down to the 2's, but I'm just going to stop right here because here's a matching set. So the square root of 32, set comes out to be 4, 1, 2 left over. For the square root of x to the third, that's 3 x's, 1 set comes out, 1 left over. So now when I put them back together, just like how we multiplied with radicals before, the 2 numbers on the outside become a product, 4x, and the numbers on the inside become a product, 2x. So that would become 4x square root 2x. Now, what if we made it cube root? So now I have the cube root of 56 r to the 8th s to the 4th. Doing 3 separate parts, 56 r to the 8th and s to the 4th. So 56, 8 and 7 come to mind. Now 8 and 7, the 7's not going to do much, but the 8 becomes 3 2's. So the set of 2's come out, and then the 7 did not have a set, so it's left inside. For the r's, 8 divided by 3 is 2. It goes, we got 2 sets coming out, but it doesn't divide evenly, there's 2 left over. So we'd write r squared cube root r squared. And if you're not sure, you can write out 8 r's and circle 3 at a time to see, oh, there's my 2 sets, 2 left over. S to the 4th inside the cube root. 4 s's, 1 set comes out, 1 left inside. So I've done them each separately, now I have to put them all together. I have my outside values, 2r squared s. I have my inside values, don't forget the cube root, 7r squared s. And then I've simplified this monomial. So now we keep going. If we had the third root of r to the 14th s to the 9th, 14 divided by 3 is 4. So 4 sets are going to come out. It doesn't divide evenly. There's 2 left over. So r squared stays on the inside. So really, 4 times 3 is 12 with 2 left over. And you should always have less amount of exponents left than the index of the radical. S to the 9th. 9 divides by 3 evenly, so it's going to be s to the 3rd on the outside. So we'd read this as r to the 4th, s to the 3rd, cube root r squared. Next problem, we have this 3 on the outside. That's not saying it's the cube root, it's just a 3 we're going to multiply after we simplify it down. So let's put some parentheses there. 49 is a perfect square, so 7 comes out. X to the 9th, divide in the square root, remember we have 2 here, 4 times. We have 4 sets in there with 1 left over, because 4 times 2 is 8, leaving the odd one left. 16 divided by 2 is 8, so we have 8 coming out. So that's 8 sets of 2 gives us again 16. No y's left inside the radical, they're all gone. Now we put it together and we go 21, 3 times 7, x to the 4th, y to the 8th, square root x. For cube root with 625, 625 is 5 times 125, which is 5 times 25, which is 5 and 5. So we have these 3 5s are going to come out, but there's 1 left over. So I'm going to start right here and just kind of put it together. I know I'm going to have a 5 on the outside and a 5 left in the radical, that one right there. M to the 28th. 28 divided by 3 is 9 and 1/3, because 3 times 9 is 27 with 1 left over. So m to the 9th comes out with 1m left over. That little fraction value is what's left. N to the 12th, so 12 divided by 3 divides evenly, which is 4, so that's n to the 4th. So that's going to read 5m to the 9th, n to the 4th, cube root of 5m. Next we have this 2 on the outside, so let's kind of put out there. And we're going to start to simplify. 192 is 2 and 81. Okay, nothing's sticking out yet. 81 is 9 and 9, which gives me some 3's. So I need the cube root, so here's one set of 3's to come out, but stuck inside is this 2 and the 3. They didn't have a set, they didn't have a pair to go with. P to the 7th in the cube root. Well, 7 divided by 3 is 2 and 1/3. So I have 2 sets coming out, so that's p squared. 1 set left over, that's the p on the inside. Q to the 18th. 18 divided by 3 is 6, it's even, so all sets come out, that'll be q to the 6th. Now we put it together. 2 times 3 on the outside is 6, p squared, q to the 6th, cube root of 6p is our answer. Down here we have again a 2 on the outside, so we'll put that there, and we're going to simplify first. 80. I'm looking for 4th root, so I'm going to do 16 times 5, because I know 16 is going to give me a bunch of 2's. If you factored it differently, you'd still get to having 4 2's and a 5, but I took a different route. So these 2's come out, the 5 stays inside. X to the 8th, so I have 8 divided by 4 is 2 and it's even, so I'm going to take x squared out. Y to the 9th, 9 divided by 4 is 2 and 1/4. So 2 sets come out, 1 set stays inside. Then I got z. There's only one z, I need a set of 4, so that's going to stay there. We put it together, 2 times 2 is 4, x squared, y squared, 4th root of 5yz. Last one we have here is the 5 times the 4th root of 112. So let's take a 2 out of that. That gives us 56. 2 out of that gives us 28. 2 out of that gives us 14. And then 2 and 7. So I have 4 2s here. Those come out. We're left with a 7 on the inside. 24 divided by 4 is 6, so there are 6 sets of C that come out. 13 divided by 4 is 3 1/4. So 3 sets of D come out with 1 left inside. We put it together, we have 10 C to the 6th, D to the 3rd, 4th root of 7D.